techniques. Now, what we're going to look at precisely, we will look at the second dimension, or the first one, right? So a different way of diversifying classifiers is by diversifying the training sets. So we will learn about two techniques: the bagging technique, which we call the bootstrap aggregating or bootstrap aggregation technique, and the boosting technique, which is we will look specifically at adaptive boosting, or what we call AdaBoost. Okay, so I will just without any maths, I will give you the basic concept of these algorithms and how they work. And the idea is actually intuitive. Like, even if you sit down and think about it, how I'm going to create, different sets. The first one is quite simple. The bagging is one of the most intuitive ensemble learning methods. So let's look at this. So the bagging algorithm was, or the bootstrap aggregating algorithm was designed by Bremen in 1996. And the basic idea is to create different bags or different subsets. So each bag will have a subset of samples. Okay, so we randomly select different samples from the original data using a uniform distribution, so a uniform probability, and all are selected in a parallel manner, which means all these models can be trained independently in a parallelized way. Okay, so how do we do that? So here, let's say in the first bag, I will uniformly select these samples, like these different samples right here. So the first sample, we'll put it in the first bag. So we'll have like these samples in the first bag, bag 1. Okay, so let's say we have n original training samples. Each bag will have n prime training samples. So each bag will have exactly the same number of training samples, but n prime is smaller than n. Okay, so then there is another rule, which is called with replacement. What does that mean? It means when you're sampling, you're not really controlling what you're sampling. So you can select this guy, okay? This guy right here, you can select it once, but then you can select it twice. So it can basically be selected twice. This is what it means with replacement. It means actually you might have some redundancy in each bag, okay, of your training samples. And after doing that, randomly sampling, okay, you will put your samples into each of those bags, and then creating different samples, like selecting different samples, etc. Then what you will do is train different models. So now we're going to train our models. So we have first classifier, classifier 1, classifier 2. These can be trained in parallel, okay? Classifier 3, or maybe call it K. We have K classifiers. And how many bags we have created? We have created K bags. And in the next step, after training each of those classifiers independently, we will test the data. How are we going to test the data? So we just take our M testing samples, and then we pass them through the classifier. We'll get a prediction, and then pass them through the second classifier. This is the testing sample, get a prediction, and all of our classifiers. So we'll get our votes, right? If you guys remember, we'll get our votes if it's different labels predicted, okay? Then what bagging uses as an aggregation strategy, it uses majority voting, okay? So here, majority voting technique as an ensemble aggregation or bagging method, MV. And what does this do? Basically, let's say, for example, in the first bag, we have -1 label for the first testing sample, okay? X1, first testing sample, and +1. So the majority of these classifiers agreed that, well, the first one should be -1. So this is, the first sample. So that's how we do it. So it's by majority voting, and it's quite easy to do. Great. Now, the bagging here, what is the main idea of the bagging? Look, if we have weak classifiers, which means you have a bunch of classifiers, but your classifiers are not very good at distinguishing between the two sets, right? So they're trying their best, but still the boundary is not that good. So you can look at this boundary right here. So we have D1. it has made a lot of mistakes, so it missed these guys, right? D2, 2, okay? So this is the second boundary by the third classifier, D3. But somehow, by aggregating their votes, so here we take the overlap between the majority, so each blue region, if the majority agree that this is a blue region, so we will label it as blue. For example, for this area, okay, it's blue by first classifier, blue by second classifier, and by the third it's blue and red, but the majority said it's blue, so all of this region will be blue. Okay, so now we're partitioning this space, and you can see very nicely by combining these boundaries and these colored regions, okay, this nice partition of the data, now we have built a strong classifier and we have correctly classified all points. Okay, so generally we would say that bagging works best when you use unstable classifiers. And here, for example, like one of the commonly used ones in bagging is decision trees. And also any weak classifier that might struggle a little bit, so you can concatenate or aggregate all of them. So the concept of bagging might not work well when you're using exactly all of them are good, all of them are strong, perform well. So what's the point? So if you're aggregating a bunch of weak learners, bagging works very well. Okay. Now it boosts the performance of each of those weak learners if they were to be used independently. Now also the combination is obtained by majority voting. So this is bagging, and here let's look at bagging when we are doing regression. So this is another example. So let's say what we have here, we have a single feature, X, or observation, in the X-axis. And in the Y-axis, we have the response Y, okay? And remember, regression, we want to find a line that fits the data. So let's say here, we're just using a weak linear, like a piecewise linear model. So if we randomly sample these training subsets, so let's say this is, my training data, and we fit a line. So by fitting this line, you can see we get this first model. Now, this model does not do well, it's weak, right? It does not fit the data very well. But then we can also remember in bagging, we need to randomly sample samples, okay? So select samples randomly using a uniform distribution. So, and then we're gonna try to fit a line that goes through all these samples. And this is the second model, model 2. And we will do this again and again, randomly, randomizing many times in different ways. And we get a bunch of models. But ultimately, our hope is that once we build all these trajectories, all these models, if we average all of them, okay, then somehow we will get a very nice approximation of our data. So somehow we hope that we will get something like this, okay, a curve like that from a linear model. So it doesn't, this is it might approximate it a little bit, but you won't get exactly the same thing.